All right, let's talk about the digital ghosts that are all around us, hiding in plain sight. This is the story of operational technology, the invisible, often ancient code that's running our physical world. Everything from the power grid to the water coming out of your tap.
I mean, think about it for a second. We just expect things to work, right? You flip a switch, the lights come on. You turn a faucet, water flows. But what is actually running the show behind the curtain?
And here's the kicker. The answer is probably a whole lot older than you'd ever imagine. And that's where things start to get, well, a little bit scary. Which brings us to the core of what we're digging into today. This massive hidden cybersecurity risk that's lurking inside these incredibly old systems.
So let's get on the same page. We're talking about something called operational technology, or OT. Just think of it as the digital nervous system that controls physical stuff. Pumps, valves, motors, you name it. And legacy OT? Well, that just means these systems were built to last for decades, and they have. They were put in place years ago, and for a lot of reasons, they were just never, ever replaced.
To really put this into perspective for you, we're talking about systems running on software like Windows XP. Yeah, that Windows XP. It's over a quarter-century old. It's kind of like buying a brand new electric car and finding a cassette player in the dashboard. Except, that cassette player is controlling a city's power grid. It's wild.
So you have to ask, right? It just doesn't make sense. In a world where we upgrade our phones every 2 years, why would a company risk everything by using technology that's dangerously out of date? Well, the reasons are actually pretty understandable when you break it down. First off, the cost. Upgrading an entire factory or power plant is just astronomically expensive. Second, you can't just shut everything down for a week to install new gear. That's a huge loss in production. Then you've got compatibility. These old systems are often so custom-built the new tech just won't talk to them. And maybe the biggest one, what if the company that made the original machine went out of business 20 years ago? There's literally no one to call for an upgrade. They're stuck. Okay, so we've established we have these vulnerable, old systems everywhere. What happens when the very modern dangers of the internet come knocking on their door? You see, for decades, these industrial networks were totally isolated. They were on their own little island. But the modern push for data and efficiency connected them to the main corporate networks, and, by extension, to the internet. That convergence basically built a brand new bridge for attackers to walk right across, straight into our most critical infrastructure. And, as we've seen lately, they are absolutely taking advantage of it. And this isn't some theoretical threat. Let's look at a few recent examples. For Barnett's Couriers in Australia, a cyber attack wasn't just an inconvenience. It was a death sentence for the company. It put them out of business. Permanently. Over in Mules Show, Texas, the consequences got physical. Hackers got into the town's water system and literally made the water tanks overflow. It's a terrifying reminder that these attacks can spill out into the real world. And it hits big names, too. A ransomware attack on Welch Foods completely shut down their production. For 3 weeks, you can just imagine the financial damage and the chaos that caused in their supply chain. And these attacks aren't just random acts of vandalism. This quote from Waterfall Security Solutions really hits the nail on the head. Ransomware is a business model, a really, really profitable one. And that money is being used to fund even bigger, more sophisticated attacks on these exact kinds of vulnerable systems. So the problem is crystal clear, and the stakes couldn't be higher. But, and this is a big but, it's not a hopeless situation. There are absolutely defensive strategies that can be put in place to fight back, like right now. First up, and this one is so important, is network segmentation. The best way to think about it is like the watertight bulkheads in a ship. If one part of the ship gets a hole and starts flooding, you can seal it off. The water can't spread, and the rest of the ship stays afloat. It's the exact same idea, but for computer networks. So how's it work? It's basically a 3-step process. First, you have to map out everything you have. You can't protect what you don't know exists. Second, you group things that need to talk to each other into their own little isolated zones. And third, you put up digital walls, firewalls, between those zones and get really strict about who's allowed to talk to whom. It's all about limiting the potential damage. Okay, so segmentation is like building fire doors. It contains the threat. But what about actually putting out the fire, fixing the vulnerabilities themselves? That's the real challenge, right? You can't just tell a power plant to shut down for the afternoon so you can run some updates. The only way to do it is with an incredibly disciplined, careful process. You start with that same inventory we talked about. Then you're constantly scanning for new threats and finding the right patches. But look at step 4, that's the key. An actual OT expert,
Someone who understands the physical machines has to sign off on every single patch to make sure it won't accidentally cause a bigger problem. Only then do you carefully test it, roll it out, and document every single thing. It's slow for a reason. It has to be.
Now, these strategies are essential first aid. They're the tourniquets and bandages you need right away. But to truly solve this problem for the long haul, we need to completely rethink how we design these industrial networks from the ground up.
For decades, this diagram right here, called the Purdue Model, was the gold standard. It was cooked up in the 90s, and its whole philosophy was security through isolation. You can see the rigid layers separating the business stuff up top from the physical machines way down at the bottom. The idea was that each layer was a trust zone, and anything inside it was considered safe. But here's the problem. That fundamental assumption that these zones are isolated and trusted is just not true anymore. Our modern world demands data and connectivity. Those old walls have been completely torn down, and the whole model is now fundamentally broken.
And that brings us to the final piece of the puzzle. We need a new blueprint. A blueprint for resilience that accepts that everything is connected and builds security for the world we actually live in today, not the world of 1995. And this slide just shows that evolution perfectly. On the left, you see the past, that old, stiff, layered Purdue model. But on the right, that's the future. It's a distributed, interconnected web that's designed from day one for a constant, secure flow of data. Let's break down this shift. We're moving away from a rigid hierarchy to a flexible, interconnected network. We're throwing out the idea of trust zones and adopting a zero-trust mindset, which basically means trust nothing and verify everything always. And instead of clunky, direct connections, we're moving to what's called a publish-subscribe model. Think of it like a secure newspaper. Data gets published to one central spot, and any system with the right permissions can subscribe to it. It's way more efficient and secure.
So if you take one thing away from this whole thing, let it be this. The old way of building isolated digital fortresses with high walls just doesn't work anymore. The future is about creating resilient ecosystems where security is smart, flexible, and built into the very fabric of the network from the start.
And that leaves us with one final, pretty heavy question. Our entire physical world, our lights, our water, our food, everything, it all runs on a foundation of code. We've seen that a lot of that foundation is old, fragile, and breaking down. We know how to rebuild it, to be resilient. The only real question left is, are we going to do it in time?